Okay, question 39. First thing I would do here with A is multiply that bracket out. So you get 3 cosec squared theta minus 3 cosec theta equals 5 cot squared theta minus 9. Alright, and then when it comes to this, we're going to look for a quadratic, right? That's what we want to achieve with this. And we've got to get the same sort of function involved. Now you've got cosecs here, but you've also got cot, so we've got to sort that out. Now the one function we can't change is cosec, because you've got cosec theta here, that has to stay like that. So what we'll do then is change that cot squared, so it's in terms of cosec squared. Alright, and if you remember, the way we go about that is going back to C1 basics. If you think about sine squared plus cos squared is 1, okay? So you remember that, and then we try and get cot squared from here. So to get cot squared, we need to divide by sine squared. Okay, so you just have a go. It's you're either going to divide by sine squared or cos squared. So and then divide by sine squared in this case, because I know that'll give me the answer. Sine squared divided by sine squared is 1. Cos squared divided by sine squared, well, cos over sine is cot, so it'll be cot squared theta. And 1 over sine is cosec, so 1 over sine squared is cosec squared theta. Okay, so then from there then I've got cot squared theta equals to cosec squared theta minus 1. Alright, so I can use this result to sub it in there. So if I go back now to the top line, 3 cosec squared theta minus 3 cosec theta equals 5 cosec squared theta minus 1. So substitute the cot squared in, take away 9. Okay, multiply this out then, so try and simplify it as best as you can. So we get cosec squared theta as a positive. Okay, so times that out there. So what I'll do is I'll get everything onto that side, because it'll make my cosec squared positive. So I take that over, it becomes a minus, so I end up with 2 cosec squared theta, because 5 take away 3. Take that over, becomes plus 3 cosec theta. And then you've got this minus 5 minus 9 already on this side, so that's minus 14 equals 0. Right, so you've got a quadratic now, all cosec theta. So, you know, nice and straightforward. And when it comes to solving this, right, whatever method you want to use, okay, you're used to, you know, a lot of people use this method here where, because it's 2 cosec squared theta, we'll put 2 cosec theta in both brackets. Okay, because it's 2 cosec squared theta there. And then over here, then we'll do this multiply add thing. Now we want to multiply. Now, because there's a number here, we times these, don't we? So we want them to multiply to be 2 times minus 14 is minus 28. Add up to give 3. Okay, so that's what we want. So we've got to think of two numbers, multiply to give 28 and add up to give 3. Now 7 and 4 work. That multiplies to give 28. Add up to give 3. Well, to give 3, it does add up, doesn't it? That would need to be a minus 4, wouldn't it? 7 minus 4 is 3. When you multiply these, you get minus 28. So it works. So plus 7 here, minus 4 there, equals 0. But don't forget, because I've times by 2 here, right, this method works, but you need to pay back, then you need to divide by 2 for it to work properly. Now when you divide by 2 then, look for common factors, and there's no common factor there, so we leave that as it is. But it's a common factor here of a 2, so take the 2 out. Okay, and then the 2's then will cancel with this 2 here. Okay, and always will, and you end up with that there. So you get 2 cosec theta plus 7 equals 0, or cosec theta minus 2 equals 0. So that means then cosec theta equals minus 7 over 2, when you take the 7 over and divide by the 2, or cosec theta equals 2. Now we can't solve involving cosec, right, because we don't really want to use that graph. So what we do then is rewrite this as cosec is 1 over sine, isn't it? So 1 over sine. So 1 over sine is equal to this, which means then sine would be the reciprocal of this. You flip this, okay? And the same here, this is 1 over sine. 1 over sine is equal to 2, which means sine then will equal the reciprocal of this, which is a half, okay? So you get those two results out there. So we're going to draw a sine graph, okay? To be able to establish this. First thing I would do is find one result for each of these. And remember now, because we're working in degree mode, we need to change this, because my calculator is set up in radians. Change this into degrees. And then I've got my little d there, so we sorted. Let's just work out the angle we've got here, minus 2/7. Okay, so that comes out to be minus 16.6, and then the other one then is a half. Now I know this one to be 30 degrees, right? So, you know, I can check it if I wanted to, but it is 30 degrees, and it is 30, I've made a mistake there, but I'm confident it's 30, okay? You can double check me on that. So we've got that there. Now we're going to draw the sine graph, okay? Now the answer's got to be between 0 and 360, but what you notice is now on this, right, even though it's got to be between 0 and 360, we've got a minus 16 here as our answer, so we need to sort of understand that that's got to be part of our sort of graph drawing here exercise, right? So we'll have minus 16, so we need to go back to minus 90. And when I do this, I do sort of every 2 centimeters to represent 90, okay? So you know, or every 3 centimeters, up to you, but every 2 maybe is fine, okay? So I'm going to just mark it slightly there so I know where 90s are, going up in 90s. So we've got 90, 180, 270, 360, and then that's minus 90 here. So I'm going to draw my sine graph, okay? So my sine graph then goes something like this. Okay, and of course we need to go back as well to there. Maximum for sine is 1, minimum is minus 1, and then we just take these answers there, minus 16.6, which is about there, which was minus 2/7, okay? So, so you can see that, and draw a line at minus 16.6, okay? But actually, I'm not interested in that, I don't want that, but I'm going to use this here, okay, to represent, slightly off there, I'm going to use this here to represent these two answers here. So to get this one, and this one, I need to see the symmetry. Now if that's minus 16.6 taking me back that way, I need to go 16.6 going this way. So my theta then will be 180 plus 16.6, okay? Or then this one will be going back this way, so 360 minus 16.6, okay? So you can work that out. It'll be 196.6 or 343.4. Okay, the other solution then is when it's equal to a half, so that one's a lot easier, 30 degrees. Okay, so you draw a line up there, 30 degrees. So you've got 30 there, and you've also got this one here. Okay, and this is going back from 180, so theta would equal 30, or 180 take away 30, so theta would equal 30 and 150 degrees. So you've got your two sets of answers.